For part AI, to find the height of ramp R, we must substitute x equals to 0 into the equation 9x plus 36y minus 2430 equals to 0. To find the y-intercept, which is the highest point of the ramp and thus is the height. By substituting x equals to 0 into the equation, you will get 36y equals to 2430. And therefore y will be equal to 67.5 cm. Thus, the height of the ramp R is 67.5 cm.
For A part 2, we need to find the horizontal distance of ramp R. Given that ramp R lies on the x-axis, we know that the y value will be 0. Now, when we sub in y equals to 0 into equation 1, we will get 9x plus 36 times 0 minus 2430 equals 0. We can bring the 2430 to the other side, making it positive. 9x equals to 2430 and thus x equals to 270 cm. Therefore, the horizontal distance of ramp R is 270 cm.
For question B, to find the length of QO, you will have to visualize the ramp from a different perspective. So, as you can see, the triangle on the left side, it is the original question given to you. However, we are going to have to flip it around so that we make Q over here the base of the triangle. What we are doing here is basically changing our perspective, and once we flip it around, we will actually see that QO over here is the height of the triangle, since this part over here is right angled. So after this, we will first need to find the area of the ramp R and also the length of Q. To find the area of ramp R, we will be using the normal triangle formula, which is just half times base times height. So in the previous question, you have found the length of W, which is over here, 270. So you use that answer to get your 9112.5 cm squared. After this, we will be using the formula for the length of a line segment to find the length of Q. So the formula goes like this: square root x2 minus x1 squared plus y2 minus y1 squared. Since our ramp at the point O, it actually starts from the origin, your x1 over here and your y1 over here is actually just 0. So what we are applying here is the Pythagoras theorem, where a squared plus b squared is equal to c squared. After your calculations, you should get 278.30 cm, leaving your answer in 5 SF so that your final answer will be more accurate. After this, we'll be finding the area of the ramp using the hypotenuse, also known as your Q, as the base. Since we have found the length of Q over here, we'll be able to apply the normal triangle formula half times base times height, so that we are able to find the height, which is over here, QO. So after doing your calculations, you should be able to find your final answer as 65.5 cm over here in 3 SF. Therefore, the length of QO is 65.5 cm.
To find the gradient of ramp R to determine whether it is safe to use, we will use the formula for gradient of a line. And since we found the coordinates of points previously found in part AI and part AII, which is this one and this one, they are the y-intercept and x-intercept. Hence we sub in the values, 67.5 minus 0 over 0 minus 270, we will get a gradient of negative 1 over 4. However, to do comparison, we must multiply by 3 to make the same denominator. And since 3 over 12 is below 5 over 12, it is safe to use.